Okay, today we're going to talk about cube roots. Before we do, let's go over the warm-ups. Now, there's one thing that you need to understand. The square root of 12, I know it's a square root because I don't have a number right here. If I had a number there, then it would be a different root. No number means square root. Now, 12 is not a perfect square. A number multiplied by itself will not give you 12. So I have to factor it. 2, 6, 2, 3. Okay? Now, I have a pair of 2's. So those 2's get married, become 1, and move out of the factor house. The square root of 12 is just like this. 2 times 2 times 3. I need to know what factors, when multiplied together, give me 12. Well, 2 times 2 is 4, times 3 is 12. I'm sorry, I said factors. I meant prime numbers. What prime numbers, when multiplied together, give me 12? Well, 12 is the same as 2 times 2 times 2. Now, I have a pair of 2's. Anytime you have a pair of primes, they get to move out of the factor house. So I can move, those 2 get married and become 1, and they get to move out of the factor house. Well, negative 1/2 is already out there. So now I bring a 2 out there. Unfortunately, the 3 cannot move out. So I have to keep the 3 inside the factor house. Negative 1/2 times 2 is negative 1. I still keep my square root of 3. That's my answer. Okay? Now, it's negative 1 square root 3. We move on to the next one. The only thing inside the square root is a 16. Now, I know 16 is a perfect square, but I'm going to factor it anyways. It's 2 times 8, which is 2 times 4, which is 2 times 2. I have 1 pair, 2 pairs of 2's. So, the square root of 16 in primes is 2 times 2 times 2 times 2. These 2 get to move out, and these 2 get to move out. They get married, they become 1, 2. So, outside of my factor house is 2 times 2, which is 4. What happens to my factor house? This really seems to confuse you guys. What happens to my square root? It goes away. There's nothing left inside, so it just disappears. The square root of 16 is 4 because 4 times 4 is 16. What do I do with my 9? It just stays on bottom. It stays right there as 9. I can't do anything with it because it's just 9. It's not the square root of 9. If it was the square root of 9, I would have changed it to 3. Now, can 4 over 9 be reduced? Is there a number that goes into both 4 and 9 evenly? Nope. There's my answer, 4/9. Number 3 is a yid bit different. Number 3 is the same thing as the square root of 13 over the square root of 81. Both of these numbers are inside the square root, so I have to square root both of them. In this one, only the 16 is inside the square root. Now, ring, ring. Hello? Oh, it's your math teacher again. They're thanking me because when they taught you prime numbers and told you you were going to need this in high school, you didn't believe them. You're welcome. Well, guess what? Blah, blah. Well, guess what? Today, you're going to need to understand what prime numbers are. Is 13 prime? Yes, it is. I know 13 is prime because when I go to try to factor tree it, can 1 go in the 13? Yes. 1 times 13 is 13. Are there any other numbers that go into 13 evenly? Nope. So only 1 in 13 goes into 13. That means it's prime. I won't be able to do anything with this square root of 13. It's going to stay square root of 13. Are there two numbers? Or I'm sorry. Is there one number when multiplied by itself gives you 81? 9 times 9, right? So the square root of 81 is 9. Am I done? Yeah, there's nothing else I can do with that. That's your answer. Here's the problem. For years you saw things like this in math. Yay, 10! I like that. That's a nice answer. What's this? That can't be the answer, because that doesn't look like 10. I want to see 10. Oh, sorry. That's your answer. It's simplified. And that's all you were supposed to do, is simplify it. So here is a bonus question. Here's the bonus round. Can you please classify the square root of 13 for me? I'm going to go ahead and pause the video, because we may be here a while. Okay, we're back. We figured out that the square root of 13 is irrational. It only took us about 25 minutes. They won't know. They weren't here. So it'll be fine. Okay, now we're looking for cubes. I know we're looking for cubes because inside this little thing right here is a 3. This means cube root. Here's the bad news. You can do cube roots on the calculator, but it doesn't simplify it. It gives you a decimal answer. Here's how you do it. You hit Shift, and then right above your square is your cube root. So you hit your square root after you hit Shift, and you see how it gives you a cube root. Go ahead and put 80 in there. Equals, what does it tell you? 4.30886938. That number goes forever and ever, never ends. Your calculator just has to round. So you're not going to be able to use the calculator to simplify this. I will let you know, last year, a couple of kids figured out how to get this thing to simplify it. I don't know how to do it. If you figure it out, good on you. Let me know. However, on the test, you'll have to show your work. You'll have to show your work. So here we go. I have my 80, 2 and 40, 2 and 20, 2 and 10, 2 and 5. Now, how many are we looking for to move out? How many are we going to need to get to move out? We're going to need to get 3s. Right here are 3 2s. Now, these are some weird New Age hippies, and they go ahead and get married, and the 3 become 1 and move out. Some sort of hippie freak cult where 3 people can get married. That's not legal in the United States. Okay. 3 people get married and move out. So these 3 2s become 1 2, but what has to stay inside my cube root? Okay, so the 3 2s become 1 and move out. What gets left inside the factor house? What? Not 2 out of 5. 2 and 5, and I multiply those together and I get 10. That's your answer. 2 times the cube root of 10 is your answer. This is something that is very difficult for you kids to understand, and I apologize. I don't know why. Okay, so let's go with 144. 144. Okay, I'm going to go 2 and... Now this is where you can use a calculator. 144 divided by 2 is 72. So I can go divided by 2 is 36. Divided by 2 is 18. Divided by 2 is 9. And then I get 3 and 3. So now I have 3 2s. They move out. Do I have any other 3s? Do I have any other triplets? Really, where's my other triplet? But they're not the same. 2, 3, and 3 are not the same, so they're not a triplet. Triplets look exactly the same. So I have to make sure you keep a cube here. Okay, so what do we have left? We don't have any triplets left. We have 2 times 3, which is 6, times 3 is what? 18. So 18 goes inside my radicals. All right, that's my answer. Yes. Okay, we had a very good question. The question was, how come I didn't circle all 4 of the 2s? I'm only looking for triplets. I only want 3s. So, only 3 get married and become 1. 4s, if this was 4 roots, then I would circle all 4 2s. But I don't have the 4th root. I have the cube root. All right? Okay. Over here we have fractions. This is just like the square roots. This is the cubed root of 48 over the cubed root of 1,000. I will let you know, cubed root 1,000 is a perfect cube. How do you get a perfect cube? Well, Brian, what's 2 times 2 times 2? 2 times 2 is 4, times 2 is 8. So the cube root of 8 equals 2, because it's a perfect cube. 2 times 2 times 2 is 8. All right? What's 3 times 3 times 3? What does that equal? That's right, 27. So the cubed root of 27 equals 3, because 3 times 3 times 3 is 27. Perfect cubes are harder to memorize than perfect squares. But I will let you know, the cubed root of 1,000 is, anybody know what the cubed root of 1,000 equals? 10, because 10 times 10 is 100, times 10 is 1,000. So the cubed root of 1,000 is a perfect cube, it's 10. However, you solve this just like we showed you. Each number is in the cubed root. Let's look at one last thing. Let's look at letters. Okay. You want to take 3's out. So right here I have 3 x's. So how many x's are going to come out? Not 3. The 3 become 1. So 1x comes out. Here with my y's, 2, 3, 4, 5, 6, 7, 8, 9. How many cubes, how many triplets of 9 do I have? 3. So 3 y's come out. Now you can just divide this number by 3 and your answer is how many come out. Here's where you run into a problem. Let's assume that this was y to the 10th power. Well, how many times does 3 go into 10? It goes in 3 times with a remainder of 1. So 3 goes into 10 3 times, 9, and I have a remainder of 1. This is back in 3rd grade. Now, so if this was to the 10th power, how many y's would have to stay in? How many y's would have to stay in? No, just 1. Just 1. Because you only have a remainder of 1. But I don't have that. I've already told you 27 is a perfect cube. What is the perfect cube of 27? 3. So number 5 is 3xy to the 3rd power. All right, kids. If you're watching this online, you have any questions, please come in and ask. Have a good day. Bye-bye.